Okay, in this section we're going to discuss reinforcement detailing. Now the standard gravity anchor utilizes 3 different sizes of steel reinforcement. A01 or number 6 bars compose the longitudinal straight bars here. These provide flexural reinforcement for the beam. A02 or number 5 bars are used as erection hooks and are analyzed separately in the constructability checks. A03 or number 4 bars compose the stirrups. These provide shear reinforcement for the beam as well as hold the longitudinal bars in place during construction. Now, Chapter 7 provides a series of requirements for reinforcement detailing. While most of these sections apply to construction techniques, for example, 7.3 will tell you about bending rebar in the field. Some notable design sections include the following. So 7.2 is minimum bend diameter, checking that the minimum bend diameter of any bar is greater than 4 times the bar diameter. 7.5 talks about tolerances, and this is a great section to reference when you're creating your table of construction tolerances for preparing for the field. 7.6 talks about spacing limits for reinforcement. Part 7.6.1 applies in our case, so we must confirm that the parallel spaced bars are greater than 1 inch or 2.5 centimeters apart. 7.7 is concrete protection for reinforcement, and part 7.6.1 applies in our case, so we must confirm, 7.7.1 applies in our case, so we'll take the maximum value of 3 inches or about 7.5 centimeters for concrete against exposed earth, which is noted here, condition A from that section. Now 7.11 is transverse reinforcement for flexural members. The first portion, 7.11.1, refers you back to section 7.10, which comes with a list of requirements for columns. So not all of these will apply to our beam, but notably I wrote down over here for you 5.1 tells us we need closed stirrups and a minimum of number 3 bar for the size of our longitudinal bars. 5.2 gives us the vertical spacing requirements that are on this diagram here. And 11.2 tells us that if we're experiencing any torsion, we need to confirm that we have closed stirrups made out of a single piece of rebar. And now section 7.12 and 10.5 will deal with shrinkage and temperature reinforcement. We'll skip ahead to section 10.5 to be comprehensive in the realm of minimum reinforcement. The final check is to confirm we have enough steel for the strength of the section in shear and flexure, and to do that we'll have to set up all the loads and go through the design process. We'll do that later. So right now we're just going to talk about the 3 requirements for a minimum reinforcement. And first is temperature and shrinkage. The area of steel should be, for grade 40 rebar, it should be 0.002 times the area of the concrete. And for this, we're going to use the area within the stirrups. So I'm going to draw an arrow to the square, and this is a designer decision to use this area instead of the entire gross area of the concrete beam. Because if we use for the entire gross area of the concrete beam, this wouldn't pass, but we are only needing this smaller section to resist shear and flexure, so as the designer, I've chosen to validate this by saying because we are well above our capacity and the beam is getting cast into a greater structure, we're going to use this smaller area. But ultimately this assumption can be left up to your design engineer in charge. Now section 10.5 has 2 equations. 5.1 is AS min is greater than 3 square root of F prime C over Fy times the area, and equation 3 is 200 over Fy times the area. So we need to make sure we satisfy these 2 equations. The only situation in which we don't need to satisfy these equations is if our AS actual, so our actual amount of steel, is greater than or 1/3 greater than or 1.33 times the required amount of steel for strength, which we'll go into calculating later on.